Hello, class. I'm back. I want to finish up from today when we were doing earlier when we were doing applications of these exponential and logarithm problems. So we did pH earlier of any solution, and we're going to work back with the next problem with pH 2, and this part of doing logarithms. Okay. So we're going to be using this again, this statement in regards to pH on the next problem. We did this one earlier in class, but we're going to do the next one. So, example 3, use pH in an application. Wetlands are classified as bogs, fens, marshes, and swamps based on pH values. A pH value between 6.0 and 7.5 indicates that the wetland is a rich fen. When the pH is between 3.0 and 6.0, it is a poor fen. And if the pH falls to 3.0 or less, the wetland is considered or is a bog, right? And this is from data from where it shows the data. Suppose that the hydrogen ion concentration of a sample of water for the wetland is 6.3 times 10 to the negative fifth. How would this wetland be classified? So we have to use the pH to classify this wetland. Now, first thing I'm going to do is let me go back and write our pH statement. So this is what I'm going to write. That's our pH statement. pH equals negative log of our hydrogen ion concentration, right? So that's what we do know. What we know for this particular wetland, this sample of water, we know that the ion concentration of this sample is 6.3 times 10 to the negative fifth. That's what we do know about them, right? That's what we do have. Okay. Now, because we know that, first thing we want to do is, because we know the hydrogen ion, we need to substitute that in here. This is where we plug it in. We know that. So we got pH equals negative log of that. So we're going to say 6.3 times 10 to the negative fifth. Okay. Now, you all should be able to see, because all I did was substitute in. Now, look at this right here. Let me highlight this. Multiplication. We just went over the properties of logarithm. So here you should see, okay, I can apply product rule. What does product rule says? Product rule say I can separate them by what? Addition. Let's do it. Still going to be negative on the outside, log of 6.3, right? Plus, no, I forgot to put this in parentheses because all of this got to be in parentheses. Why? Because I am now taking a log of this. This is what is breaking up, right? This is where you're writing out. The negative is on the outside, so you got to put that in parentheses, okay? Now, log 6.3 plus common log of 10 raised to the negative fifth. All that in parentheses. Okay. Now, the next thing you all should, we did multiplication, right? We broke multiplication down. The next thing you all should be able to see is exponential right here, right? Exponential rule, do y'all see that? You can do exponential, okay? Now, we could do negative, right? Log 6.3. And then remember, exponential mean I bring this exponent out. Negative 5, right? Log base 10. Okay. Now, we have simplified and used all the properties we can use right now. Right. So now if you want to, we could distribute this negative on the outside to this, and we can distribute it to this. So we can go ahead and do that. Let's do it. We get negative log, common, which is common log, 6.3. And then a negative and a negative give me plus 5 log 10. You all, we could just put it in the calculator like this too, and we could go from here. But one thing you all should be able to see is this right here. I gave you this as another property that says if you do something the log of a base, and then you have that same base raised to a power, they cancel each other out. Now look at this log right here, you all. This is common log. This is base 10. So you got log with a base 10, but then look what you got, an exponential that says 10 to the first. Because they're the same base, you can cancel them out. And that's what I was saying, like this cancels out. So these will cancel out, and what's left here? This is understood to be a 1 there, because that's the exponent on that, okay? So let me rewrite again, negative log 6.3 plus 5 times 1, right? And then we can simplify this as negative log 6.3 plus 5. Be careful how you type this in the calculator. Now this is going to be calculator. Because when you type this in, you got to put the negative on the outside. Then you say log. Remember, log opens up with a parentheses. Okay, write the number in, but you got to close this parentheses. You have to get it to calculate it correct. And then do the plus 5. So let's do it here on our calculators, right? On my calculator. We have negative on the outside, log. You see it opens up with a parentheses, 6.3. I got to close this parentheses. And then I got to say plus 5. Did I do? Yeah. Yeah, I did that right. Now I was making sure my number, I typed the number in correctly, 6.3 and plus 5. Look what we get. We get 4.2 around, okay? So we get that our pH here is 4.2. Based on the pH, you have to label this. You have to classify this. And look what you have to classify it in. If it's between 0.6, this is it. If it's between 6.5, then it's this. If it's 3.0 in this, then it's this. So 4.2 falls in this category right here, 3.0 and 6.0. So this is classified as a poor fan, okay? And that is just us finding pH in order for us to classify it as that, okay? The next one, okay? The loudness of sounds is measured in decibels. We first assign an intensity of I sub 0, okay? That's intensity. I sub 0 is intensity. To a very faint threshold sound. If a particular sound has an intensity I, then the decibel rating D of this louder sound is given by the following, okay? So this is what we have. Find the decibel rating of a sound with intensity of 10,000 I sub 0. Find the decibel rating. So decibel is going to stand for D, right? So here, your intensity is the following, which is your intensity represents I sub 0, which this is saying right here, well, your I, not I sub 0, sorry. Your I, that's your intensity, right? That equals 10,000 I sub 0. Now, knowing that, because it says your intensity right here, it says intensity, and this is what it is. So where I see I, this is what I have to plug in. Where I see I, this is what I have to plug in right here. So let's do it, you all, because we got to find the decibel rating. D equals 10 log of I is 10,000, I sub 0, and then the formula just has I sub 0. Now, you all should see the very first thing that can cancel out. First thing y'all going to tell me is the I sub 0, but I'm going to write it over so you all can see. I don't want to write it right there. Now, look what we left with. D equals 10 log 10,000, right? Now, this right here is calculated. All this is calculated, y'all. I mean, you could type that in and get calculated, okay? Type it in and you will get calculated, right? So, or you can type the entire expression in and we can get calculated. So let's see what our decibel rating is right here. And type it in the calculator. We got 10 times, right? Log of what, 10,000? Look what we get, 40. 40 is what we get. Okay. And this is like just some ways of how we use logarithm in an actual real world problem, or you having to apply logarithm to a couple of these problems, okay?